Hi, my name is Bahadur Akhmedov. In this video lecture, we are going to discuss how we can prove the infinite limit. So essentially, the limit of the function is equal to infinity using the definition of the limits. So essentially, what we need to do is we need to say that, hey, I can get the x very close to this limit from the right-hand side part in this example, so that the value of the function is going to be huge. It's going to be even bigger than my threshold. So essentially, I can say, hey, so let's say I can choose my threshold m. So can I make my function, which is in this case 1 over x, even bigger than threshold? Yes, I can do this, it appears, by just choosing the x very close to the 0 from the right. So essentially, the definition is looking like this. So the if x minus 0, in this case, without an absolute value, is smaller than delta, then, so where I can control the delta, then the function 1 over x is going to be bigger than my some threshold m. Okay, then I can choose this delta very small so that my function is becoming very huge, so even bigger than this m. So well, it's not easy. It's not difficult to find a delta because I can use this equation 1 over x as greater than m. Then I can take the reciprocal from both of the parts. If you take the reciprocal of the left-hand side, it's going to be x. The reciprocal of the right-hand side is going to be 1 over m. And since I took the reciprocals, the equality signs is going to change. It's going to be smaller. So essentially, if I choose the x smaller than 1 over m, 1 over x becoming bigger than m. So the delta can be chosen as 1 over m. So essentially, if x is smaller than the delta, which is equal to the 1 over m, then my function 1 over x is becoming bigger than m. So I can sketch the graph of this function in order to show what do I mean. So the graph of this function is looking like this. And you can see here that if you go to the x from the right, so the function tends to go to the infinity, plus infinity. And if you go to the x from the left, the function goes to the minus infinity, right? And essentially, what does it tell you? That, hey, you can get the distance between 0 and the x very small. For example, this delta, this distance is going to be the delta, so that your function is becoming really huge, even bigger than some threshold m. Okay, so you can choose any threshold, for example, here, this m, and you can get your function even bigger than this m if you choose the distance between x and 0 and x as 1 over m, or like a delta in this case. So this is what does it mean, the precise definition of the infinite limit. It means that you can get your function always bigger and bigger any threshold by just by just controlling the distance between x and its approach, its limit. So that's it. So I hope that this was helpful for you.